Sine, cosine, and tangent in 60 seconds. Draw a line segment from the origin at an angle theta and go out a distance 1. Then the x-coordinate of the point you're at is cosine of theta, while its y-coordinate is sine theta. This is also a point on the unit circle which has radius 1 and is centered at the origin, or the set of points at distance 1 away from the origin. Notice that we formed a right triangle with hypotenuse 1. The side opposite the angle has length sine of theta, while its remaining or adjacent side has length cosine theta. If the angle is theta but the hypotenuse has length r, then we will have a similar triangle whose hypotenuse length is r times as much. This means its opposite and adjacent sides will be r times as much as well, so their lengths will be r sine of theta and r cosine of theta respectively. So opposite over hypotenuse equals sine of theta because the r's cancel, and r sine of theta over r, while adjacent over hypotenuse equals cosine theta. Finally, tan of theta is defined to be the lengths of the opposite over adjacent of the triangle with hypotenuse 1, which is sine of theta over cosine theta. But tan of theta can be defined to be the lengths of the opposite over adjacent of the right triangle with hypotenuse r, because r sine of theta over r cosine theta is the same. And tan of theta will also be the slope of the line having the points of the origin and cosine theta sine theta, and then you can verify that r cosine theta, r sine theta is on this line as well.